This is section 10.5.1, volume. In this section, we're going to look at the formulas for volume of polyhedrons. First, let's define a polyhedron. A polyhedron is a solid figure bounded by polygons. On this slide, we can see three different polyhedrons. A rectangular solid, which is bounded by sides that are rectangles, a cube, which is bounded by sides that are squares, and a pyramid, which is bounded by sides that are triangles and a base that is a rectangle, or actually can take on a lot of different polygonal shapes. You can see the volume formulas below. For the rectangular solid, it is length times width times height. If our rectangular solid happens to be a cube where all sides are equal, we have volume equals S cubed, S standing for side length. And the volume formula for a pyramid is 1/3 times the length, the width, and the height, which can also be expressed as 1/3 times the area of the base times the height. And you can see the capital B down here, and it's a capital B because this stands for the area of the base. So of course, if your pyramid has a rectangular base, you would do the length times the width. If we get into some more complicated pyramids that have triangular bases or even other polygonal bases, you'd have to calculate the area of the base. On this slide, we're looking at the volume of a cylinder and a cone. The cylinder is on the left, and the volume formula here is volume equals pi r squared h. Now this formula should make some sense because volume equals pi r squared, that's the volume, or that's, the area of a circle. And you can see that the cylinder has two circular bases, one on the bottom and one on the top. So that's area of a circle. Then we multiply it by the height of the cylinder, and that's what gives it the third dimension and makes it the volume formula. Then we have a right circular cone. Now it's a right circular cone because this is a right angle. And the volume formula for this is 1/3 pi r squared h. So again, you can see the pi r squared in there. That's the area of the circular base. Then we have times h, which is the height. So pi r squared h is actually the volume formula of the cylinder, but since this is a cone, it's only 1/3 the volume. Next, we're going to take a look at the volume of a sphere. A sphere is the set of points in space equally distant from a given point, its center. So this definition sounds very much like the definition of a circle. However, the definition of a circle is the set of points in a plane equally distant from a given point. As you can see here, the definition of a sphere is the set of points in space, meaning three-dimensional space, equally distant from a given point, its center. So, you can see in the diagram on the left, we have a circumscribed cylinder to a sphere. So circumscribed means that the cylinder encloses the sphere. The reason I'm showing you this diagram is because it helps us understand the volume formula of a sphere. Let's look over here on the right. We have the diagram of the sphere with the radius marked. And we derive the volume formula. Notice we start with volume equals 2/3 pi r squared h. Well, you'll notice that pi r squared h is the volume formula of a cylinder. However, what we know is that the sphere has only 2/3 the volume of the cylinder with the same radius. The next thing we do is we simplify the height of the sphere. Looking back at the diagram on the left, notice that the height of the sphere is equal to 2 radii. So if you take the radius of the sphere and double it, you're getting the height of the cylinder. So what we do over here on the right is we change the height of the cylinder into 2 times the radius of the sphere. And then the last step is to simplify this. So we have 2/3 times 2, which gives us 4/3 here. And we have r squared times r, which gives us the r cubed here. So the volume formula of a sphere ends up being 4/3 pi r cubed. So these are the volume formulas for the shapes discussed. Your main job will be to use these formulas to calculate volume, but it does help to understand how these formulas are related to one another, as we discussed in the video. This has been section 10.5.1 on volume.